Thanks, Mairead. Good morning, everyone. So I'm going to talk to you about accounting for thermal bridging in the DEAP assessment and look at its impact in BERs and on Part L compliance. So I'm just going to run through kind of the context, looking at DEAP and Part L compliance, then looking at the thermal bridging factors in DEAP. Simon covered it a little bit this morning. Looking at the supporting documentation for the anything better than a 0.15 Y value. And then I'll do a quick run through at the end around the DEAP Part L compliance reports as well. So Part L of the building regulations requires dwellings to be designed and constructed to limit the amount of energy and CO2 emissions required for the operation of the building. And a DEAP calculation must be carried out to demonstrate that new dwellings have met this requirement. The technical guidance document Part L provides guidance on demonstrating compliance with these requirements. And some of these requirements of the technical guidance document are checked in DEAP. So just looking at those requirements, there's requirements in relation to whole dwelling performance. That's requirements for primary energy consumption and CO2 emissions. We're required to limit those. That calculation is carried out in DEAP. And there is a compliance check carried out for that. There's also backstop requirements in relation to individual measures. And the way that the calculation works is that you must exceed in one or more of those minimum backstops for the individual measures in order to achieve the whole dwelling performance. You can see also that some of the requirements are checked in DEAP, but not all, and I'll cover that later. So what is DEAP? It's the dwelling energy assessment procedure. It's the compliance tool specified in Part L of the building regulations. It's the official Irish methodology for calculating the energy performance and associated carbon dioxide emissions for BERs. And it consists of a software tool, which is DEAP 4, and DEAP methodology documents. It models the expected energy consumption and associated CO2 emissions for the dwelling under standardized operating conditions. So it's a calculated asset energy rating rather than a measured operational rating. And its calculated energy usage is based on the dwelling and not on the occupants. In order for you to be able to compare like with like, there's a number of standard assumptions made and applied to each assessment regarding the number of occupants, the heating patterns, the level of lighting, and the climate. So the calculation takes account of the energy demand for space heating, water heating, lighting, pumps and fans, and cooling and renewables as well if present. And it calculates the primary energy consumption and CO2 emissions. So it calculates the primary energy consumption in kilowatt hours per meter squared per year and the carbon emissions in kilograms CO2 per meter squared per year. And they're the two figures that appear on the building energy rating certificate. For new dwellings, then you can go on and do another calculation, which is the calculation to demonstrate compliance that the requirements of the technical guidance document have been met. So to demonstrate compliance, there's compliance indicators provided for whole dwelling performance, so primary energy consumption or the energy performance coefficient, CO2 emissions or the carbon performance coefficient, and then it checks individual performance levels for renewables, for fabric U values, and for air tightness. So to calculate the primary energy consumption in kilowatt hours per meter squared per year for the assessment dwelling, that's the figure that's shown on the BER cert. And it calculates the EPC by dividing the calculated kilowatt hours per meter squared per year by the primary energy consumption of a reference dwelling, and the details of the reference dwelling are set out in Appendix C of the technical guidance document. The reference dwelling is essentially the same building built to 2005 standards, and the technical guidance document requires that the maximum permitted EPC is 0.3, or roughly 70% better than a building built to 2005 standards. In DEAP, when you're working through the assessment, you can see the primary energy value, and it will also give you indicators on how you're doing in terms of compliance. So you can see here in the screenshot that it's met compliance. The target is 0.3, and in this example, the EPC is 0.288. It also checks against the maximum permitted carbon performance coefficient, carries out the same calculation, taking account of the kilowatt hours, the kilograms of CO2 per meter squared per year, dividing that of the assessment dwelling by that of the reference dwelling, and the maximum permitted value is 0.35. So all of the inputs in the DEAP calculation impacts on the CO2 emissions and the kilowatt hours per meter squared per year. So also then impacts on the EPC and CPC calculation. So just looking at how thermal bridging then fits into all of this. The calculation takes account of the energy demand for space heating. That is impacted by the heat losses through the fabric, and we take account of the heat loss through the plane elements and through the junctions. That impacts on our space heat demand. It therefore then also impacts on the kilowatt hours per meter squared per year, and it also impacts on the calculated EPC and CPC. So then to look just a little bit more at the fabric heat loss calculation, and I know this was covered already in Simon and Andy's presentations, but in DEAP, the fabric heat loss calculation takes account of the heat loss through the plane elements and also the heat loss through the junctions where those plane elements meet. So the heat loss through the plane element, which would be the floors, walls, roofs, doors, windows, depends on the area and the thermal transmittance or the U value of that building element. So in the illustration there, it's shown by the green areas. And then we also have to take account of the heat loss through the junction, which is marked by the red dashed line in the image. So in general, the SEAI value is the additional heat flow through the linear thermal bridge, over and above that through the plane elements. And the SEAI value is calculated using numerical modeling, which Andrew went through this morning, and is dependent on a number of factors, including the geometry of the junction, the DEAP measurement conventions, and the level of insulation in the junction. So within DEAP, to account for the heat loss through the junctions, we don't enter the SEAI value for each junction. Instead, we input a global figure that takes account of the heat loss through all of the junctions. So the heat loss associated with all of the junctions in the dwelling is entered as a single figure called a thermal bridging factor or a Y value. So the SEAI value is heat loss through a particular junction, and the Y value is the heat loss through all of the junctions. The options for Y values are set out in the technical guidance document. And Simon went through this morning, but there's three options. One is 0.08, where you've adopted the ACDs, or you can calculate it if you have SEAI values for all of the junctions, or you can use a 0.15 if you're using alternative details. In the technical guidance document, reference is made to key junctions. The guidance that we've given to BER assessors is set out in our DEAP guidance document, and it states that the following types of junctions are considered key junctions where they include a heat loss plane element. So that's floor to wall junctions, wall to wall, basically all of the junctions covered in the ACDs. The list is not exhaustive. Any junction in the dwelling that has a relatively long length or a high rate of heat loss, or both, should be considered a key junction, and they would typically impact on the Y value calculation. Just to point out that it's not the BER assessor's role to identify key junctions, it's the role of the designer to do that and provide the information on the key junctions to the BER assessor. So we can see that there's two options when you're using ACDs. So I'm just going to run through those quickly. I know Simon covered it this morning, so I'm not going to spend too much time on it, but it's a set of junctions for the most common construction methods in Ireland. It's published by the Department of Housing, and for each junction in the ACD, you're provided with a drawing of the junction, construction requirements to achieve the necessary thermal performance, requirements to ensure continuity of air barrier, and the SEAI value for the junction detail. The SEAI values for each of the junction details are provided in the tables D1 to D6, and the SEAI values can be used to calculate the Y value in DEAP. And there's 3 SEAI values for each junction detail, and the SEAI values are selected based on the U values of the plane elements forming the junction. The SEAI values are applicable for a range of junctions, and to use the ACDs, the U values must be within the applicable ranges. So to calculate the fabric heat loss, you enter the U value and the area for each heat loss plane element. So that's for every wall, floor, roof, window, and door. The Y value is applied as a multiplier, so increasing the fabric heat loss, and it's multiplied by the total heat loss element area. So the result is then added to the heat loss through the plane elements. So the higher the Y value, the higher the fabric heat loss, the worse the BER. So just looking at the impact of the thermal bridging factor, I've used the example from the technical guidance document to illustrate this. The calculation has been carried out using a 0.15 Y value, a 0.08 for the ACDs, and a 0.05. And you can see the impact on the fabric heat loss. It's much higher for the 0.15. It's also impacts then on the primary energy value that's displayed on the BER certificate. And it also impacts on the EPC, CPC and ORIOR calculations. In this example, the building does not meet EPC compliance when you use a 0.15 or a 0.08 Y value. Just some things to be mindful of, and Andy touched on this as well before the break there. It's really important that this is considered as early as possible at the design stage. So at the design stage, the designer or the person who will be confirming compliance with the building regulations should identify each junction in the dwelling, ensure it meets the requirements of the technical guidance document, consider the compliance approach that they're taking in relation to thermal bridging options, identify if any or all of the junctions need to be assessed by a thermal modeler, and assess the impact of the Y value option in relation to EPC and CPC compliance. So it's really important to engage a BER assessor as early as possible in that process so that they can advise you on the impact of the Y value on compliance. So just looking in more detail at a 0.15 and default value and the impact of that. That value is used when there's no information on thermal bridging or insufficient information to support a better Y value. So that's the default in DEAP. It's applied for any existing building, but also to new buildings where there is insufficient information to support a better figure. Just to be mindful that even for this figure, even though there is no information on the SEAI values given to the BER assessor, the designer still must satisfy themselves that they've assessed the junction for risk of surface condensation, but this doesn't impact on the BER. So to look at the impact of a 0.15 Y value, it is really significant in terms of the impact on fabric heat loss. We apply the 0.15 as a multiplier within DEAP, and that gets added to the plane elements. It's the same as adding a 0.15 to every U value that's inputted in DEAP. So you can see that if you adjust the U values to take account of the Y value, it has an enormous effect on the heat loss. And as I pointed out earlier, the overall energy performance requirements for this example are not met with a 0.15 thermal bridging factor, and additional measures will be required to get EPC compliance. The next option in the technical guidance document is the 0.08 Y value. That's the DEAP default Y value for new dwellings using ACDs. It's used when a new dwelling has been designed and constructed in accordance with the acceptable construction details. In this example again, you can see the impact. By reducing from the 0.15 down to the 0.08, it's reduced heat loss by nearly 20%. But still the overall energy performance requirement is not met with the 0.08 Y value. And again, additional measures would need to be required to achieve EPC compliance. The other option in the technical guidance document is to calculate the Y value. And you can calculate a Y value when you have basically have psi values for all of the key junctions in the dwelling. You can use the default psi values from the tables D1 to D6 in the technical guidance document, or combine them with certified psi values. So you can use a combination of psi values from the ACDs and from certified values, or you can use a full set of certified psi values to calculate the Y value. But the key thing is that you will need psi values for each key junction in order to calculate a Y value. The use of a calculated Y value is typically of benefit to projects, and for the majority of dwellings, the calculated Y value will be below the ACD default of 0.08. And that will give us then a better compliance results and better BER. So in the example in Appendix C, there's a 0.05 Y value applied. Applying that reduces the fabric heat loss by 26%. By using that calculated Y value, EPC compliance is now met, and there's no additional measures required to get compliance with that. So how do you calculate a Y value? Simon went through this morning, but essentially you need to identify all of the junctions, include the key junctions in the calculation, measure the length of the junction. That should follow the same measurement conventions that you use to measure the dwelling for the BER assessment, to measure the plane elements. Identify the psi value for each junction, multiply one by the other, add it up for all of the junctions and divide it by the total exposed surface area, which again should match the measurement in the DEAP assessment. The BER assessor needs to be provided with a schedule of the key junctions and the psi values for each junction. So just to look at the supporting evidence requirements for the BER assessor, you can see that the impact of having a lower Y value has a significant impact on Part L compliance and on the BER on the certificate. In DEAP, supporting evidence is required for any non-default value that's used in the BER assessment. So the principles in general to BER assessments is that the actual data observed on site takes precedence. Where the data item is not observable, it should be detailed using documentary evidence, which must be obtained and retained within the assessment records. And where the data item is not observable on site or via documentary evidence, then the default is used. So in relation to ACDs, if you don't have the supporting documentary evidence, it will be defaulted to a 0.15, which will have a significant impact on compliance and on the building energy rating. The requirements for the documentary evidence requirements for any input in DEAP is described in the DEAP survey guide, which you can download. But for new final and existing dwelling extensions, you would need reports of works or as-built drawings or specifications signed by the person responsible for building regulation compliance sign-off. And for new dwellings or extensions that opt out of building control and do not have the sign-off, the non-default data must be supported by sufficient documentation in the form of invoices, photographs taken during construction, and drawings. So if you're using a 0.08 Y value or a calculated Y value in the DEAP assessment, you must supply the BER assessor with the required documentary evidence. So the purpose of that is to confirm that for a Y value is that all the junctions in the dwelling have been considered, all key junctions have been identified, each key junction has been designed and built in accordance with the ACD or certified detail, and the non-default Y value has been calculated correctly. So all of that needs to be signed off by the person signing off on building regulation compliance. There's further information on this in the DEAP manual, the DEAP survey guide, and in a supplementary guidance document as well that's available online. And I'll run through where those documents are at the end of this. So the documentary evidence required by the BER Assessor to support a Y value better than 0.15 are drawings showing all of the junctions in the dwelling, a schedule of junctions, a copy of the ACD or certified detail for every key junction, and if the Y value has been calculated, a copy of the Y value. Sometimes a third party might carry out the Y value calculation and give it to the assessor, or the assessor may carry out the Y value themselves. The documentary evidence needs to reference the dwelling being assessed and be signed by the relevant person, confirming that the key junctions identified were designed and built in accordance with the associated ACD or certified detail. In our guidance document online, it gives as an example of a set of documentary evidence required to support a non-default Y value. And it goes through each of the requirements and illustrates what that would look like. So for the set of drawings, they're usually prepared by the designer of the dwelling. They should reference the dwelling being assessed, and on each of the drawings, all of the key junctions should be indicated. There should be a schedule of junctions with a clear reference for the dwelling being assessed, the list of junctions in the dwelling. The relevant person may consider a particular junction not to be a key junction, and the schedule should state that it's not a key junction. For each key junction, the associated ACD or certified detail must be identified, and the schedule should be signed by the relevant person, confirming that the junctions were designed and built in accordance with the ACDs or certified details. We also provide a copy of the relevant ACDs and certified details to the assessor. And where the certified SEAI value is used, the junction detail clearly referencing the certified SEAI value and thermal modeler name and registration details must be provided to the BER assessor. And then as part of the documents retained by the assessor is a copy of the Y value calculation. And if it's calculated by a third party, the BER assessor will need to check that. And we also have then, as Simon went through, the Y value calculator on our website. So there is responsibility to ensure that each junction design meets the technical guidance document requirements in relation to limiting the risk of surface condensation. And Simon went through that, the requirements this morning. That does fall outside of the BER assessments, and it's not considered here, and it won't be considered by the BER assessor either. And the primary responsibility for compliance with the requirements of the building regulations rests with designers, buildings, and the owners of buildings. Designers, builders, and owners of buildings. And the BER assessor is responsible for ensuring the BER assessment is carried out in accordance with the DEAP methodology. So just I'm going to cover the Part L compliance report that you can generate from the DEAP assessment. So within DEAP, you can generate two types of report, a dwelling report, which contains all of the inputs in the BER. So it's a PDF you can save as a record of all of the inputs that were used to generate the result. And there's also a shorter report, which is the Part L report. So to generate a report in DEAP, you must complete out the assessment. You run through all of the tabs on the left-hand side, and that covers space heating, water heating, fabric, cooling, and renewables. And once you complete out all of the inputs, you will get a result, and you'll get compliance indicators. You will get the result in the compliance indicators in advance of publishing the certificate. So you can run a number of assessments, look at a number of different options through it ahead of publishing the assessment. Anybody can do this. Anybody who has access to the DEAP software can can log into the software and carry out assessments and generate dwelling reports and Part L reports. This report has been generated ahead of the publishing the BER search. So it has a draft watermark indicated on it. That indicates that it's not associated with a published BER. It does contain the compliance indicators. So the 4-page report will show all of the key inputs into the BER, and they can be generated for different compliance options. It is ideal that a BER assessor carries out the calculation and generates the reports, and that's to ensure that the calculation is carried out in accordance with the DEAP methodology. And just to note as well, you can generate any number of reports, and it helps designers to look at the best approach for them for their building to get compliance. But any changes that occur during construction, there's often many changes that occur for various reasons. They should be assessed during the construction phase to ensure that the completed building will still meet compliance. If the assessment is ready for publication, all of the inputs have been completed, the BER assessor will then upload the evidence to support non-default values in the assessment and generate the advisory report. Documentary evidence is uploaded to the system to include any evidence to support non-default values, and for new dwellings that can be significant. Once it's published, then you have access to a read-only file, and you can generate the dwelling report, the Part L report, and the cert and the advisory report for that dwelling. The report will then have a watermark of the BER certificate number across the report, and that indicates that it is associated with a published building energy rating certificate. The report demonstrates compliance with some of the requirements in the technical guidance document, and it shows indicators for the EPC, CPC, ORIOR, the U values, and the air permeability test. But it's important to note that not all of the technical guidance document requires are covered by the Part L report. And then the dwelling report is a record of all of the inputs in the BER. This one doesn't include the Part L compliance indicators, but it does provide the BER calculation results. And then you can check the details of any published BER if you've either the BER number or the MPRN. You can do that following this link here. You can check the register on our website. So just to quickly run through additional resources on the SEAI website. These are contained in the building energy rating section under home energy and in the section for support for BER assessors. You can access the DEAP software from here and download all of the methodology documents. There's three core methodology documents. There's the DEAP manual, the survey guide, and the DEAP guidance document. Thermal bridging is covered in the manual in Appendix K, and the survey guide in Section 5, and there's detailed examples of supporting documentary evidence in the guidance document. There's additional support as well. There's a lot of information there on building fabric inputs for the BER. And there's a webinar that was run for assessors in December as well, which you may find useful. So just to conclude, the SEAI value is the heat loss associated with an individual junction, and the thermal bridging factor, or the Y value, is the heat loss associated with all the junctions in the dwelling. The Y value options in DEAP are set out in the technical guidance document. At 0.15, 0.08 were calculated. Lowering the Y value will improve the BER and EPC and CPC compliance. The DEAP Part L report contains compliance indicators for some, but not all, technical guidance document requirements. And it's important to engage with a BER assessor as early as possible to carry out the DEAP calculation at the design stage, ensure the calculation is being done in accordance with the methodology, advise on the impacts of the Y value on EPC and CPC, advise on the impact of any changes during the construction phase, and advise on the supporting documentation required for the final BER.